A mass on a spring oscillates with a period of 2.5 seconds. What is its frequency? So we know the period is the amount of time of one oscillation. In simple harmonic motion, we have the period is set equal to 2 pi. And then since it's a spring, note how it's a spring, we want to do m over k. The things that affect the period for a spring is the amount of mass and the spring constant. K is the spring constant. So we already know the period. The period is 2.5 seconds. Now we want to find the frequency, which is 1 over the period. So then the frequency would be 1 over 2.5, which is roughly 0.4. So the frequency is equal to 0.4. A mass spring system has a frequency of 5 Hz. What is its period? We've talked about periods within a spring, and it was T is equal to 2 pi square root of m over k. However, since we know the frequency is 5 Hz, we can use this to find the period. And then the period would be, since it was 1 over t, which is the period would be 1 over the frequency. So 1 over 5 is also 0.2 seconds. So that is the units for the period. A 0.5 kilogram mass is attached to a spring with a force constant of 200 newtons per meter. Find the period of oscillation. So the period for a spring is 2 pi square root of m over k. So we know everything that we need. We have it in kilograms and we have the spring constant. So it's 2 pi, plug it in, 0.5 over 200. And let's see what we get. 2 pi, and then square root 0.5 over 200 is going to be roughly t is equal to 0.314 seconds. Oops. A pendulum completes 15 full oscillations in 30 seconds. What is its frequency? So you want to find the time for one oscillation. So you want to do 15 divided by 30. So that would be one oscillation per 2 seconds. So that would be the frequency, 0.5 Hertz. A mass oscillates on a spring with an amplitude of 0.3 meters. What is its maximum displacement from equilibrium? So amplitude is the maximum displacement. So they give you A, which is 0.3 m, more meters. And this is the maximum displacement. Amplitude is shorthand for maximum displacement. A 0.25 kilogram mass oscillates on a spring with a period of 1.5 seconds. What is the spring constant? We know the period of a spring is 2 pi square root m over k. So we are given the period, but what I like to do is I like to get my variable set up first. So t squared is equal to 4 pi squared m over k. And I need to isolate to k, so t squared times k is 4 pi squared and times m. And so k would be equal to t squared, k is equal to 4 pi squared m over t squared. And then we can plug all those values back. So 4 pi squared, the mass is 0.25 kilograms, all over 1.5 squared. Let me just plug it in to see. So 4 pi squared, 0.25, 1.5 squared. And that is going to be roughly, ignore that. K is equal to around 4.39 newtons per meter. A 1.5 kilogram block is attached to a vertical spring with a constant of 250 newtons per meter. How much does the spring stretch at equilibrium? So this is a bit different. We're going to have to use the spring force equation. And so force is set equal to the spring constant times the displacement. So the force in this case will be the force of gravity, so mg, and we're trying to find the distance or the displacement in this case. So this would be mg, and we would set it equal to the spring constant, and so the displacement is mg over k. So delta x is going to be 9.8 times 1.5 over 250. 9.8 times 1.5 over 250 is, so delta x is roughly 0.0588 meters. So that would be the spring stretch at equilibrium. A simple pendulum has a length of 0.8 meters. Find its period. So notice how this is a pendulum. So a pendulum sort of looks like this. It might be hanging off of something. So this would be at equilibrium, but of course, when it kind of moves in this direction, right? And it follows through with the conservation of energy around, and so it would come back in that direction. So to find the period of a pendulum, it relies on 2 pi square root. It relies on the length and on gravity. That's all it relies on. So if we need to find the period of a pendulum, it would be 2 pi. We are given the length. The length is 0.8. Gravity. So gravity for Earth would be around 9.8. So to test it, it would be 2 pi. And then square root. Divide 0.8. 9.8. You would get roughly, the period is equal to 1.795 seconds. and that would be the period. A 1.5 kilogram mass oscillates with an amplitude of 0.25 meters on a spring with a force constant of 150 newtons per meter. What is the max speed? So to find the speed, we want to use conservation of energy. Conservation of energy would be 1/2 mv squared would be equal to the potential. If it was a pendulum, it would have been mgh, but in this case, it would be the spring kind of potential, spring potential. So 1/2 k delta x squared. And we want to isolate for velocity. So the 2's cancel with the 1/2, as well as actually nothing else. So it would be velocity squared. The mass still has to go. The velocity would be the square root of k delta x squared over the mass. Let me just make a better square root. So that would be, plugging all those values in, the k, 150, the delta x, 0.25 squared, and over mass, 1.5. So let's see. So we have to do square root, divide, 0.25 squared, 1.5. That's going to be roughly velocities 2.5 meters per second. A 0.5 kilogram mass is attached to a spring with a spring constant of 200 newtons per meter and oscillates on a frictionless surface with an amplitude of 0.15 meters. What is the total mechanical energy of the system? So the energy would be equal to the 1/2 k change in x squared. That being said, this is a spring, and this is the energy inside of a spring. However, we know that in simple harmonic motion, there is something known as amplitude, so an amplitude is a holder for the displacement. So we can rewrite this as 1/2 k a squared, and then we can plug in the points. So for k, we have a value of 200, so the energy would be 1/2 200. The amount of amplitude is 0.15, all that squared, and that gets me down to energy is equal to 1/2 multiplied by 0.0225, and the amount of energy would be equal to 2.25 joules. A 1.5 kilogram block is attached to a horizontal spring with a spring constant of 250 newtons per meter and oscillates with an amplitude of 0.2 meters on a frictionless surface. What is the maximum speed of the block during its oscillation? So we want to try and use the conservation of energy. In this case, we want to do 1/2 mv squared to get the velocity, but now we have to set it equal to the potential in terms of the spring. If this was a pendulum, it would have been mgh, but since it's a spring, we want to do 1/2 k change in x squared. The 1/2's cancel, so you get velocity squared is equal to k change in x squared over m. So then the velocity is the square root of k change in x squared, or delta x over m. Now, delta x, or the displacement, can also be rewritten as the amplitude, so you're really left with k amplitude squared over m. And so now we can plug everything in. The amplitude is 0.2 squared, and it's going to be multiplied from 250. Just going to write that a bit smaller. And then the mass is 1.5. So the velocity is going to be, I have to calculate it via calculator. So 250 multiplying 0.2 squared over 1.5, you get roughly 2.58 meters per second. A simple pendulum consists of a 2 kilogram bob attached to a 1.5 meter long string. The pendulum is displaced by a small angle and released from rest. Which of the following changes would increase the period of oscillation? So when we're looking at a pendulum's period is set equal to 2 pi square root of L over G. And so the only factors that change the period would be the length and the gravitational field. Now, to increase the period, we either have to increase the value for the length. Either the length has to increase or the gravitational has to decrease to increase the period. So if the gravitational decreases, we would have a larger value for the period. So mass doesn't affect it, amplitude doesn't affect it. So if we go shorter with the length, then that would mean we would have a smaller period. So decreasing the gravitational field strength would increase the period. A 0.75 kilogram mass hangs from a vertical spring with a constant of 120 newtons per meter. The mass is pulled down 0.1 meters from its equilibrium position and released from rest. What is the angular frequency? So angular frequency is equal to 2 pi over the period. And we know the period of a spring is equal to 2 pi and the square root of m over the spring constant. So let's find the period first. So the period is going to be 2 pi square root of the mass, which is 0.75, and the spring constant, which is 120. So let's see, 2 pi times the square root of 0.75 over 120, and that is roughly 0.497. So the angular frequency is going to be, let's just see, we have to now plug it in here. So 2 pi over 0.497, and the angular frequency is going to be around 12.64 radians per second. A 0.5 kilogram block is attached to a spring and undergoes simple harmonic motion with an amplitude of 0.2 meters. The block reaches a maximum speed of 1.5 meters per second at the equilibrium position. What is the spring constant, of the spring? So spring constant. So since we're given the speed And the way we found speed previously was through the conservation of energy. 1/2 mv squared, right? And then we set it equal to 1/2 k delta x squared. And so we also changed that to the amplitude. So it was the amplitude squared. So now we want to isolate for k. So the 1/2s go away. And so we want to divide by a squared. So we want to do mv squared over a squared to get us to k. And so k would be, see here, 0.5. And then velocity is the 1.5. So 1.5 squared over the 0.0. No, actually 0. So the amplitude is 0.20, sorry. But squaring that would give us 0.04. So in the end, for k, with a spring constant, we get roughly 28.125 newtons per meter.